need to prove this. One, like basically summation of all the odd integers is equal to n square, holds for all positive integers n. So it means that we need to prove it for all the natural numbers. Let's start our proof. So whenever it's given, no, it holds for all the natural numbers, we usually go towards induction. So step one. So here it's for all the natural number. Let's take the smallest one, n is equal to 1. This is your base case. So what does LHS gives me? 1. What is our RHS gives me? 1 square, that's 1. So when we equate the two, LHS is equal to RHS. Therefore, we can say n is equal to 1 is true. What we're going to do next, we will assume in the step 2, we will assume that n is equal to k is true. Then what you're going to get? 1, 3, 5, so on till 2k minus 1 is k square. Let us label it as the first one. Okay, this is our first. Now we will be using this. So I have assumed this. Now we're gonna prove it that if it holds for k, then it holds for k plus 1. And k is any natural number. So it means we're gonna using this, we're gonna generalize it, right? To prove that n is equal to k plus 1 is true. We get 1, 3, 5, so on, 2k minus 1, 2k plus 1 is k plus 1 whole square. Let's start with this. So what is LHS? 1, 3, 5, so on, plus 2k minus 1 plus 2k plus 1. Okay, now till k minus 1, it's straight away from the step 2. Let's just sub in over here. What we're gonna get? K square plus 2k plus 1. Okay, either you can do middle term splitting, but as I can see that it's a plus b to the power of 2. I'm able to identify that. So it's a square plus 2ab plus b square. So here your a is 1. Here your a you can take as k and b as 1, or other way around is also fine. You're gonna get the same thing. Okay, so it's up to you. Either you remember this identity, you apply it, it will be much quicker, or you can do middle term splitting or quadratic formula. That's also fine. So it gives you k plus 1 whole square, and that's your RHS. So what we're gonna say now, that this gives me n is equal to k plus 1 is true. And since k is any natural number, so therefore by principle of mathematical induction, it holds for all natural numbers. Okay, here should I use natural numbers or positive integer? What is given in the question? Let's just go move up and see. Look, it's given for all positive integers n. So I'm going to use the same thing instead of natural number. So it holds for all positive integers n. So yeah, that's it for this question. I'm going to see you with the next problem on induction. Keep smiling, keep shining. Bye-bye.